So before we get started, is there anyone here from the St. Louis area? Okay, move to the back, move to the back. Way back. We're going to talk some hockey today. As you know, it's the 7th game of the Stanley Cup today at 5. Two people from the St. Louis, wow. So sorry you don't have any chance. I apologize for that. Oh, no counting chickens. I'll watch with great interest. So I guess we can get started. People might filter in. So I'm going to talk about this project that you heard about yesterday when Greg Simon was giving that really good talk that we heard after lunch. Very inspirational. He mentioned a couple of things. He mentioned mCODE and Codex, and those are a couple of things that I'll touch on today. Before we get started, just briefly introduce myself. I'm Mark Kramer. I work for mCODE. I'm the chief engineer of the Health Technical Center. And mCODE is quite prominent around here. I guess we've given several talks, and some of the things that we've heard discussed are up here. You've probably heard of Cynthia, the synthetic record generator. Inferno it was mentioned by Steve Posnack of the ONC. That's the test certification harness that they're going to use for the US for API certification. Talk about mCODE and Simple, and we're also doing some work in clinical decision support. So lots of things going on. For you latecomers, I just want to let you know we want the cup. And we're going to take it tonight. So what's the problem besides the blues? The problem is we have 1.7 million new cases of cancer in the US each year, okay? And of those, the folks that have cancer, only about 3 to 4% are in clinical trials. Those in clinical trials, the data is very meticulously collected, at least for the purpose of those trials. And you get research quality data. For the other 96 or so percent, they undergo treatment at various clinics and radiology sites and surgery sites, and their data is generally scattered. And we heard about this again yesterday from Greg Simon. That data is also low quality, very spotty, and generally lost to us. Now, there have been efforts to collect that data from EHRs, often just through the process, a painful process of manual curation. There have been attempts to use NLP, but it's only partially successful because if you've got very poor quality data, there's no way you can, kind of upgrade the data. Unless it's there, it's really can't be recovered. So there's a lot of missed opportunities. And when I say missed opportunities, it's learning opportunities. So there's a big difference between a clinical trial and the general population, and we'd like to know how drugs work in the general population, which is generally older, sicker, browner, more diverse than the clinical trial populations. And I don't know much about cancer myself, so I'm not even going to try and interpret this, but this is a slide that I borrowed that has a typical case of breast cancer. Someone's diagnosed, they take several different drugs over time, and they also have some genetic testing. And as the disease progresses, the genetics of the disease can change. The drugs that you want to that you can apply at a given time can change. So now, suppose that there's been a remission, and you're 3 or 4 years in this into treatment. And you're looking at the patient history as an oncologist and trying to decide what to do next. And there's, I looked this up yesterday, 66 approved breast cancer drugs. Here's a breast cancer patient. And they can be used in combination. So you can imagine the number of combinations that you could come up with. And there are also clinical trial drugs, experimental drugs that are available on demand. If you apply as a special case, you can use them. And also there's a law's last-ditch kind of access to experimental drugs. So there's a lot of options. So this is a difficult situation, of course. You have someone who's very, stressed out about their health coming to consult with an oncologist, and there's limited factual information. The decision may depend on a lot of factors. You can see them over to the right. I won't read them off because we'll hit on those. And also, the patient preference is also very important. They may have had enough treatment. They may want to. They may be in good health and ready for more treatment, or not. So we want to be able to support that process. Okay, that's the main objective here. And if we can standardize the data for the 96% of patients that are not in clinical trials, collect that data in a high-quality way, and then extract it without undue effort into research-quality databases, we can then use that to inform future care, right? So that's the goal. It's really to get to the state of a learning healthcare system and minimize the number of lost opportunities. And the slogan that we use for this is that every patient's journey should inform or improve all future care. So that's our ultimate goal. And to get there, we've coined this term mCODE. It's the minimal common oncology data elements set, so that we're trying to just standardize a common core of data elements for cancer that's cross-cutting. So it's not particular to a certain type of cancer, although we have focused on solid tumors for now. But we're trying to get enough people on board and cancer centers on board to actually collect this data in a unified way so that it actually can form the sort of the fabric of interaction between cancer treatment centers. And in this journey, we've been very fortunate. We've got a lot of collaborators, and you can see them up here. Biden Cancer Center has been a strong proponent, as you saw yesterday. ASCO, the American Society of Clinical Oncologists, has been a very strong supporter from the start. And we've recruited a number of different cancer centers to participate, and I would say very enthusiastically. This has been a project that has kind of taken off by itself. It's attracted people because they realize the scope of the problem is big. And just this was a little more than 1 week ago at the ASCO annual meeting, which is 40,000 attendees, so way, way bigger than anything that we participate in as members of HL7 or the FHIR community. The presidential address, that's Dr. Monica Bertagnolli at the podium there, announced mCODE and explained in her own words that we need to build this common structured language for every EHR so that we can share that data. And so it's a little bit more than just talk at this stage. We're actually in a couple of clinical trials and also pilots. And you can see that it's involving almost 10 different sites around the country right now. So it's gaining some traction. And we've been very grateful to have the forward thinkers in the community being willing to take up this and help mature the idea. The other thing that is brand new with HL7 is what we're calling Codex. So you can think about the M as the minimal part of the Common Oncology Data Elements, and the X is some other use case. So Codex is extending that minimal set to particular use cases, and we're very much inspired by the Da Vinci Project, which brought together payers and providers and selected some high-value use cases to focus on. So in the cancer domain, there are lots of use cases besides the one that I'm going to talk about, which is comparative effectiveness. There's some payment issues. There specialty cancers, so we can talk about breast and prostate and lung and all the other cancers. Those are very particular. There's surgery. and radiology, and there's some work now to get radiology standardized. Kurt and Penrad have been working on that. So you can see that, well, we haven't picked out the use cases, but we're inviting folks to help to join us and help prioritize those use cases. And we're going to use the FHIR Accelerator program, if you're familiar with that. It uses some HL7 resources to help speed things along. So what I really want to do today is not just talk about this project, but talk about how it might affect the work that you're doing if you have a similar clinical situation and you want to capture that clinical area into a set of profiles, FHIR profiles. And so I'm going to take you on this journey, and really it starts back in 2015. You know, it seemed at that point, FHIR 1.0, we could see that there was this awesome thing that would allow us to exchange data, and it's going to be a very powerful technology going forward. And MITRE were very quick to embrace that future. You know, having this awesome thing meant that, you know, we needed to focus on the data. If you have transport and you have an API, the question is then, what is the data that you send over that API? And the core resources are far from adequate when you think about a specialty area like cancer. Well, in fact, there's 100 medical specialties and 60,000 human diseases. So there's a lot to do that isn't in the so-called 80%. I call that 80% the 1%, because 99% of medicine is not in that 80% of FHIR. So it's all about the data, and you know, if you have bad data going in, you're going to have bad data going out. So you know, even though you have this awesome thing called FHIR in the middle, you know, if you have your bad data going in, you're going to get it going out. So in 2016, MITRE started the Standard Health Record Collaborative, and the idea here was to try and standardize health data in various different areas. And we started a open source project, which still exists today, starting with identity management, moving to emergency care and primary care, and we started building this stuff right off the bat. And what we found out that there was absolutely no interest in joining that collaborative. So we had, I think, the right idea, but maybe not the right approach in the standard health record. But we were very fortunate to have a connection. Our CTO, Jay Schnitzer, knew Dr. Monica Bertinoli, who became the president of ASCO last year. And Monica came with this problem. She was the one that showed the chart of the patient progressing through cancer and said, this is a problem we have to solve. And she used her 1 year as ASCO president to spearhead this project as her primary contribution and project for her year. So she really pushed it forward. And we actually did two projects. We did you may have seen in HL7 a breast cancer IG come through 2 ballots last year. And this year, we're going to ballot mCODE. So at first, we started with breast cancer, which is a very important case, very prominent disease. But then we said, OK, well, there's only so much you can do there. What we really need is to spread that out to all cancers and collect the basic data for all cancers. So we switched gears to focus on mCODE. And last year, ASCO helped us assemble a team of specialists in cancer, and you can see a number of clinical areas there: oncologists, certain specialty types of cancer, radiology, surgery, public health, informatics, a very august group of cancer doctors, and sitting around the table to try and determine what mCODE should be. And one engineer, which was me, feeling very overwhelmed by that situation and trying to herd everyone towards useful informatic discussions, not always successfully. So this team got together starting last August and met several times. We formed groups to do surveys of prior work. There's quite a bit of it, and quite a bit of our effort has been to try and harmonize with prior work so that we're not unnecessarily, reinventing the wheel. And by surveying the prior work, we also saw what other people's opinions were on what the minimal core set of elements were. So we came up with what we call the bubble diagram. And this was kind of divided into some of those categories you saw in the disease progression: patient, things that describe the patient, and things that describe the disease, the treatments that have been that the patient has had, and the outcomes that they've experienced. So we threw some things, based against the wall, and that's where we essentially started with this august committee of many oncologists. But we felt that there wasn't really a way to make decisions, and we needed something more specific. So we focused in on a single use case. There were actually 2 patient stories that went with this, but the use case was shared decision making or comparative effectiveness analysis, where it's the same scenario I painted a minute ago, where you're coming in for treatment, you have treatment choices. The doctor can help you by telling you about these choices, but ultimately it is the patient's choice. And so trying to help that patient out by saying, here's a cohort of patients that is like you, and these are the outcomes and the number of hospitalizations maybe that they've had, the financial impact that this has had. This helps, make it personal and help, it's not all theoretical up in the clouds. You can relate to the fact that, you've had peers that went through a similar situation. So, this is Compass here is a Smart on FHIR app that we're building to actually implement this. And, this is just a notional screen, but I'll show you the whole architecture around Compass. So by focusing on this use case, we were able to pare down the number of data elements. And the clinicians always talk about data elements, and it's not like resources that have a number of different properties. They always fling the data elements as if they're completely independent, and so it kind of drives me crazy. But we had to explain to them some things about modeling, and then I gave up and just let them play in the land of data elements all they wanted and tried to do the right thing. We tried to take them through this process of profiling, which is defining the problem, including the use cases, talking to clinicians, finding out what they need to know to solve that use case, generating an information model, mapping that to FHIR, figuring out where that, what we need to profile, generating those artifacts, implementation, and then deploying. And the different roles, the clinicians are involved up front and back, and we have informaticists in the middle, and terminologists and implementers, and all this was completely wrong. Actually, what happened was more like this. This is the fanciest animation I can get. So it's everything that begins with RE: rethink, redo, refactor, rename. There was a lot of repeating involved with this process, and I'll show you actually. Part of this is our fault because we decided we'd start modeling while the discussions were still taking place. So we were going to do agile, and iterate. So we were redoing on purpose, but this is so we were storing some of the files in GitHub, and this is our log, and basically over the 6-month or 7-month period, except for Christmas break there, it was pretty busy. And actually, this is an animation that I really like. Every blue line represents an edit to a file. And you can see the people that are involved. And when they come from the way outside, and that's a new piece, that's a new model that's happening. So, I think we're in Christmas break, but you can also see the commit messages that are happening here. And it gets pretty busy. And, it was just actually really crazy. I mean, we were always refactoring and redoing, and just hundreds and hundreds of times. So finally, we finished. You can see one of my major collaborators there is May Terry. Some of you might know May from HL7, and she did an excellent, excellent job. So we were looking at, how would we support this? And there are some excellent tools, right? You've heard, most of you probably know about Trifolia and Forge. And these are tools that are profile editors. And what they do is they put a user-friendly interface over structure definitions so that you can create a profile. And then from there, with a little bit more information, you can create your implementation guides. And we had also, thought about this, and we've done profiles in different ways, and this just didn't seem to be up to the job. Editing things one at a time would have killed us. It would have just been death by 1,000 clicks. We actually had to do massive refactoring, and these tools are very nice, but they don't really support refactoring. So we went a different way. Actually, all that standard health record stuff with the crickets, we were working all the time on better ways to do clinical modeling. And the outcome of that was something we called Simple for clinical information modeling and profiling language. And I gave a talk about that yesterday, so I'm not going to go through too much of it. But it's in the notes. I guess they recorded it like the other sessions as well. So you can look back over that. But essentially, the simple approach is really different. We have a language where we describe the clinical model, and then we execute the language, and it produces a bunch of useful stuff. And this includes profiles and IGs. And for the clinicians who couldn't understand anything about models, we output a data dictionary, which is just an Excel spreadsheet that has data elements in it. So that was the way that we communicated back to the clinicians. We're working on graphical views and mind maps, class browsers. So actually a whole bunch of things that aren't listed here come out of that one language. One of the other things that we found necessary was using multiple FHIR versions. And our pilot is with Cerner, who supports DSTU2 through Argonaut. And our single source in the simple language can export to DSTU2 and simultaneously export to R4, which is how we're bringing mCODE to the fall ballot. It can export to STU3 also, but we're not using that one. It's probably not as important version. So so basically we have one single source, and the same semantics go to DSTU2 and to R4, which is kind of cool. So we know that we're still doing mCODE regardless of the FHIR version that we're using. It's a language, and why would we want to use a language? Well, for any complex programming thing, languages beat visual interfaces. How many people use a visual programming language? How many people use a text programming language? So, I mean, if you're doing a complex project, you want text. It's more expressive. It's also faster. And I swear to you, if you are in a project like mCODE, global search and replace will be your best friend forever. It's just like, I don't know how many times I'm searching for something I did. I want to rename it. I want to find all the occurrences. This is just so important. The other thing we did, source code control, we put it on, obviously in GitHub, I showed you that graphic, and it's important that when you do that, it's not just in GitHub, but you have meaningful diffs. So if you have like something where you change a binary file and you change one thing and everything changes, it's no good whatsoever. I'll give you a quick sample. This is for tumor dimensions. You're basically, in the first two lines, you're declaring a class called tumor dimensions. It's a laboratory observation. You describe we wanted a property to tie these dimensions to a tumor. So we say there's a property, a related tumor, which is another class. That automatically becomes an extension. We don't have to do anything. Then there's a bunch of constraint statements. Here's a fixed value constraint where we're saying the code, that this is a SNOMED code which describes tumor dimensions. We don't need a data value because there's components, not data values. And so we're constraining out the data value that comes with an observation. And then this is slicing in simple. And when this started, I was like, I don't want to do slicing. I don't even know how to do slicing. I just want to say what's in the slices. And so I went to our talented developers, and they came up with a grammar so that I didn't have to worry about that. And that's, all I can handle this. So, I'm very comfortable with this kind of declarative language. And actually, this structure definition, I went back to check, and I don't know whether structure definition changed in R4, but this was 2,760 lines of JSON in the structure definition versus the 10 or 12 lines here. So I mentioned GitHub. So when we divide and conquer, you can review the changes in GitHub. This was actually a little clip, another way to visualize the changes in GitHub, how we distributed it. I don't know if I'm the master is the blue line. I don't know which branch is green, which branch is orange. But there was a lot of branching and merging. And this was great because we had someone working on the genomics aspect, someone else working on the staging aspect, someone else working on the laboratory aspect. And these would interact, so we couldn't really just completely factor them apart, but this really, really helped. And if you're interested in simple, it is an open source project. It's well documented now. We have tutorials, we have authoring guides, reference manuals, and all that is open for you to use. And I would encourage you, if you have a project that looks like it's going to be over maybe, let's say, 10 profiles, and you're actually working with a clinician or a clinician group, you're going to get stuck in the same treadmill that we were on. I would encourage you to take a close look at simple rather than using our esteemed colleagues' tools. I mean, I don't want to step on anyone's toes or maybe hit anyone unduly. But I do enjoy watching this a lot. Brian, do you like watching this over and over again? Yeah, it's just really a joy. So anyway, back to mCODE in the few minutes that we had. This is how we came out, and this is a hand-drawn picture. But this is after we pruned down the content and all that. And it's an approximate rendering of what we've got. And you can see there's 6 areas: patient, disease, genomics, treatment, outcomes, and labs and vitals. So the patient is in the middle. The patient has some vital signs as well, and we only needed height, weight, and blood pressure according to the oncologist, so the rest of them aren't there. Complete blood count and a metabolic panel, which, by the way, led to a lot of profiles. There's like, if you go to LabCorp and you go to Quest, there are 20 elements in each one of those. We are also taking the physical location of the patient, their date of birth, their gender, race, and ethnicity, which we borrow from US Core. That's all based there. We have tests for tumor markers that can happen, like PSA. We have let's go to the your upper right. That's their treatment, their medications, including treatment and intent and termination reason. Those are 2 extensions which don't exist in FHIR. And also any surgical or radiological procedures. That also has treatment intent. And so both of those are different from the base resources. These are all profiles. Let's go to your upper left. That's all the staging stuff. I'll talk about the challenges there a bit. And then the lower left is the genomics, and we spent a lot of time talking to Jamie and to Gil about the genomics modeling. And I think we've had some convergence, although our use case is a lot simpler than the full-fledged genomics report. And finally, outcomes. Outcomes are difficult to collect, so we have very little. Actually, we have something called disease status, which has values like progressing or stable or improving, that sort of thing. Very, very, very simple value set, but difficult to converge on that value set. And date of death. which is part of FHIR. So that's the scope of what mCODE is, and I think it's about, if you don't count the lab stuff, it's about 25 profiles. If you count the lab stuff, it's about 60, maybe, profiles. And the tumor marker tests are pretty open-ended, so we can't even enumerate we couldn't really enumerate them. So we had some challenges, and these are still challenges. One is proprietary terminology. So AJCC, we've been talking to them for a long time, and they hold very closely their staging terminology, and we made all the arguments we could that this would be good for them because we're putting it in a standard, but they would not let us mention their codes or their definitions in mCODE. So mCODE has empty value sets where AJCC should be. The American Joint Commission on Cancer is the organization that does staging standards. So that was a disaster, and I don't think they get it. They don't get standards. They just get the fact that they're making money off of licensing their terminology. So I will stop there because a lot of curse words are coming into my brain right now that I'm not going to do the Tourette's thing, but. And then strict or permissive. We had a lot of debates along this axis. Like the example is, how do you describe a cancer diagnosis? You could use SNOMED, or you could use ICD-10, or you could use ICD-03. And should you make just one of those permissible in mCODE? Should you make 2 of them or 3 of them permissible? And if so, which ones? And we eventually kind of caved in on our high ideals of forcing people to have one way to describe cancer diagnosis. So we actually, on this decision, we just caved. We said, any way you describe the cancer diagnosis, we'll try and process that on the back end. Just give us what you got. Then there was an axis, which I call aspirational versus practical. Like, we'd like to collect a lot of data that we can't really practically collect. So there was a lot, debate about minimal oncology data elements. What does minimal mean? And for example, some folks really wanted to collect every treatment change, unplanned treatment change. Like, why did you reduce the meds? Why did you, stop the radiation? And actually, that was felt to be a bridge too far. Like, if we asked for that, that would inhibit adoption of mCODE. So we took a middle ground there and actually just asked for medication termination reason. So when someone when a doctor cuts off a medication entirely, was it because it wasn't effective, the end of a normal course of treatment? Was it causing side effects that were severe enough to change medications? And then we had, 4 is not that important. It's just sort of a tooling problem. But we were using some code systems that weren't supported by the FHIR-IG publisher. NCI Thesaurus was a source of some codes. The genetic test registry, LOINC, doesn't cover a lot of genetic tests. And GTR is very imperfect. It's a voluntary thing, but it's better than nothing. Anything is better than nothing. But when we put these codes in our IG, you know what prints out into the IG? Nothing. Well, no, that's not true. There's a red error, nice red error. So we try and distribute this, we can't. So I don't know. We put all the codes in the comments, which just really is terrible. But anyway, we did get to an implementation guide, and this is up on build.phir.org. We're calling it a 0.9 version because we're going to ballot in the fall. That's our intent. You can see the whole thing there. It's pretty nice, I have to say. It's got a lot of background material. It has FHIR examples. It has a data dictionary that we mentioned before. So it's pretty complete. And with the simple approach to profiling, we have all these exporters or emitters that, rip through the code and then produce different artifacts, including the profiles and the IGs. But I mentioned this before, we have this data dictionary, which seems to be like the thing that clinicians would like to look at. So they're like, how many data elements are in there? Well, I don't know, because it depends how you count. Is not a good answer. 75 is a good answer, but that ignores the fact that when you collect this, there's a whole lot of attributes in FHIR that you can provide. And if you count all those, I mean, you get a completely different count. So what we did was we marked certain ones as must support, and that was our way of expressing what was in mCODE versus out of mCODE. And we inherited some of those must supports from US Core and from the genomics, and we didn't count those. So it's a little bit of gray area. So how do we put this into practice? Well, we're working with Intermountain right now, and we're beginning to work with partners to do a pilot. So basically, we have a FHIR API that's a little bit bigger than the Argonaut API. So that blue box here is the extended version of the API, because we're getting a few resources that aren't covered by Argonaut. But then from there, we are supporting a Smart on FHIR application, which we call Compass, and that's the app you'll see inside the doctor's office, when visiting your oncologist to help you make those decisions. We'd also, and this is dotted line at the bottom. I guess the dotted lines didn't come out. We'll report all that data up to CancerLink, which is the aggregation organization. But of course, they're not the only ones that can do this, because it's a standard. So the idea is not to just work with CancerLink, but whatever registry uses this data. And then at the top right, that app interacts with the CancerLink analytics database to retrieve the similar patients, the patients like us kind of thing, in order to do this shared decision making. I showed this slide already, but here's some contact information. You're really welcome to join us. It's amazing. Brian Anderson, MD, is the world's greatest connector, as far as I'm concerned. He's just completely brilliant at bringing people to the table. So we've just gained momentum like you wouldn't believe. And we're launching this Da Vinci thing for cancer, Codex. Bring your case study and join, please. So next up is Cancer Data Summit. This is an event that MITRE will host in the DC area in early October. So we're going to do a lot of things there. We're going to try and get that roadmap for where we're going long term with all these related projects. Try and prioritize what we're going to work on first. Also share experiences from the pilots and the clinical trials that are going on. And if you have questions, I can talk a little bit about that. And so it should be really cool. And I'm really excited about this project because it has a chance to impact patients' lives. And I think we all, know someone that is affected by cancer. And there's been a tremendous team. I really want to thank everyone that has been involved. This is a little out of date, and there seems to be a preponderance of MITRE people here, which is true. These are people, we're also working on some other things. They're not all working on mCODE. The mCODE team was quite small, but there's also teams that are working on data collection and how do you get the clinicians to more easily enter data into a system to reduce the friction there. And we have pilot teams that are helping deploy the pilot. So there's a lot of people involved, economists as well, and lawyers and all sorts of things. And then our clinical team, core clinical team, and community. So we've gotten a lot of support. There's John Lamka. He's been a big backer. He's going to be on our executive committee and all that. So really, really great. And then this is just, just for Brian and the rest of the St. Louis crowd. You'll never have a chance to put your hands on the Stanley Cup like I did in 2011. So are there any questions? Yes?
Did you look at being able to create a more holistic view of the patient? So very often these cancer patients will have other conditions.
Oh, yeah.
Those treatments may impact.
Sure. Yeah.
Right.
Well, I didn't mention it, but we're collecting some data. We have comorbidities is part of that, and also since we're doing like a metabolic panel, you'll know what the liver and kidney functions are, and we also have ECOG or Karnofsky performance assessments, so we know their general physical abilities. So it's not as holistic perhaps as you could imagine, but for a minimal set of things, that seemed to be where we landed. Yeah.
Just on the terminology thing, we had, so we've been doing a primary care data exchange, IG, and a lot of what you said is very, very similar to what we've had to do as well. But for the terminology stuff, we run our own terminology server, and you can actually point the IG builder at a remote, at your own terminology server. You just can't do it with the auto builder. So if it's auto building out of GitHub, you can't tell it a different terminology.
We certainly thought about that, and AJCC is in fact going to a terminology server, and if you're a licensed customer, you can hit it, right? So we don't have to have the codes and their definitions here. We can just go to their terminology server. If you've got the money to get, I don't even know, because none of their license terms allow a public domain standard to have a license. You can't. Because we just want, I mean, our bottom line is this is all open source for the benefit of everyone. AJCC won't do that. Yeah. And SNOMED, by the way, there's a bunch of SNOMED codes for staging, but they're not up to date. So one of our workarounds and one of the redos in our circle of never-ending redos was that we had SNOMED codes for almost everything we needed, but some of those were AJCC version 7 and not version 8. And then we considered that this was really perhaps putting us in a liability situation because we're obviously trying to circumvent their licensing terms. And, you know, it's like, I didn't mean to steal it, you know. It just happened to wind up in my pocket as I left the store, you know. So I didn't feel comfortable with that, and we decided to just put kind of a passive-aggressive note inside the value set that said AJCC didn't let us do this, so this is empty, you know. Another question. You were next.
So can you talk to the relationship with oncology EHRs? Like, do they already cover all these elements, but in a proprietary way? Or, and you mentioned a Cerner pilot, so maybe that would be a
right.
angle.
So I'm not as knowledgeable as May Terry is on oncology EHR because she's worked at Flatiron. But she, you know, almost all the clinicians were using an oncology EHR when they were, you know, making their suggestions and deciding what was feasible and what was not. So I can't speak to the particulars there, but there were a lot of knowledgeable people involved that I think kept us on track.
Is there any interest or involvement from those vendors?
Yes. Yes. So that's the other thing. I mean, with the influential folks, the heavy hitters that we have on board, if ASCO comes out and says, these are the things we want in your oncology EHR, I'm confident and ASCO is confident that they can get that to happen. So that's a key. I mean, if I had to draw keys to success, it's like get the right people, the right team, get the, you know, a diverse team which has all the right players, do a pilot, don't, you know, get deployments, the modeling piece of it, which I did, which was probably the least important part. That's just my, you know, goggles. So there was one more question, and then I think we'll have to.
I was going to follow up on the terminology that on the research side we use heavy use of NCIT.
Yeah.
Kind of one of the narratives
right.
Going to FHIR is that it's not as well supported.
Right. Right. Exactly.
Did you talk about some of the challenges?
We did. So we have NCIT value sets. And the challenge is that they disappear into the IG publishing machinery and never reappear. Because if Graham's server doesn't support that terminology, it's considered an error.
But that's where you can use a different terminology server. You can tell the builder to use a different one. If you've got one that you can manage and make sure everything you need is in it.
So we should talk about that, because I don't know how to redirect it. So by value set you can do that?
So we load up a terminology server with all the code systems that we need.
Oh,
the
okay.
datasets that we need,
Yeah.
And then when we build the IG publisher, when we use the IG publisher, we say, and use this terminology server.
Can we borrow yours? You're the Onto server guys, right? I love that
But
tool.
it doesn't have to be Onto server.
Yeah.
Like the IG publisher does this out of the box. It's just that the one that gets launched with GitHub hooks cannot do that.
Yeah.
The normal IG, the standalone IG publisher can. So we're talking to Graham about whether he would whitelist some terminology servers and say that I trust these ones.
Yeah.
Tell me in your IG.
I think right now they wouldn't take it for the ballot unless it was run through Graham's server. That's my understanding.
Sure. And I think that's where we need to talk to him.
Right.
But I think he's open to that.
Right. So that was I think that problem will be overcome. It's the copyrights that won't. So we're at time, I think. Thank you very much. I'll be here. I'll stick around in case you have any questions. Thanks.